Hi everybody, my name is Mutuan. So I want to help you out with a practical of preparation of copper 1 chloride, okay? So now, first and foremost, so here, so this is answer sheet that they're going to give you an experiment, right? For someone. I got this from one of the students. He say, hey Mutuan, please help me out with the practical. There's some questions here I don't know how to answer. I don't know how to balance these chemical equations. Please help me out. So now when you prepare copper chloride, this is, you put your student number, you put your student initial, then practical and lecture, name, whatever, okay? Now let's say for the chemical below, okay, let's use my pen quickly. Okay, let's just come back here. Just a second. Okay, I think we're ready. Okay. So what I'm trying to say here is second. No, just a second. It's kind of freezing. Okay, we got it. Okay. So now they say we want to explain. Okay, let's go to the question actually. So it's gonna make a lot of sense. Okay. So this experiment 2 that I want to do, experiment number 2, this one right here. So we want to do something here. What we want to do? We want to prepare the copper 1 chloride. Copper 1 chloride. So what do we need? We need some chemicals and everything that we need. Okay. So we need some sodium sulphate. This is sodium sulphate that we need. Sodium sulphite. This sulphite because it's N H2SO4. So it's sulphite, not sulphate. Sulphite. Okay. So that's the first thing we need. Another thing also we need to have a copper chloride, but the dehydrated one. Dehydrated means the one which has been diluted in other way. So this is dehydrated, it has water. That's also we need. Also we need to have what? Dilute sulfuric acid, not concentrated dilute sulfuric acid, remember that. And the molarity is 0.01 molarity of, so even when you go there to compare, make sure you read 0.01 mole of sulfuric acid. Now another thing, apparatus that you need Hotplate filter paper, beaker, see 2 of them, measuring cylinder, and the plastic what? Pipette. It could be any pipette, but say just get plastic pipette. Another thing we need what? Weighting board. You see what I'm saying? You need a weighting board. Another thing is a Buchner funnel, spatula, glass vial, and a glass or stirring rod, because you need to stir your chemical reaction so you can speed up the rate of reaction. Okay, so you need those things. So this is what you need for you to prepare copper 1 chloride, to get the copper 1 chloride. Now let's get to the business now. You see, and another thing, before you do, there's something here very, very important. I want you to understand this equation. I want you to just check this question here. This is sulfuric acid here. So sulfuric acid, sometimes it can ionize. See, if it ionizes, look at this. This is, look, H2SO4. If it ionizes, this hydrogen is going to be alone, but it's ionic, so it's going to be have a positive. And then this sulfate is going to be alone. It's going to be SO4 This is going to be alone. So this is ionic form. When it ionizes, it's going to give us this hydrogen 2. It ionizes, give it that. But now look, how many hydrogen here? Only 1. Here there are 2. See, 2 hydrogen. So put number 2 before that. And this is the same number because S is 1, S is 1. O is 4, O is there are 4 of them. So this is what is the ionic equation. Make sure you put 2 here. So and here must be plus because it must mean ionic. Ionic means when you have a plus and minus on top. So we had a concept. We'll not show you this concentrated diluted, but they say diluted. Sulfuric acid give us what? Hydrogen ion and sulfate is the ionic equation. Just like how we see it, okay? Same with you have a this is the base here, okay? This is the base because any base it has OH. So let's ionize it. So when you ionize, base it has an OH always. Base it has an OH. For example, you say sodium. This also is a base because there's a element and metal and OH. OH, anything with the OH meaning base. So the first one was acid. This acid because it has a H here, and this is the base here. Let's see how it ionizes. When it ionizes, we have a NH4 OH. If ionized, remember this is going to be alone. It's going to be NH4, but it's going to be positive. See what I'm saying? Because it's a radical, so you just put separately. And OH also you put out separate, but OH always has a negative after it ionized. See? Yes. So now either you can leave like that, or if you don't want, they say since there are 2 moles here, you see they say here there were 2 moles, so you can just say 2, and since this is NH4 is going to be 2 of them, here we must also put 2, and these 2 is going to affect even OH, means they're going to be 2 OH, also you put there 2. So just memorize, simple as memorize. Then I'm going to say give another one because we want to prepare calcium chloride, calcium 1 chloride, so you can memorize this equation. Same with the third one. The third one now, what happened is, look, now if you take this, react with this now, like direct, means if you take acid, react with base. So what is acid? Acid is look, this is not part of the next one, but I want to show you how it ionizes. It's H4 plus what is our base? Our base is NH. So when they react these two, look what is going to happen. Look, this ammonia is going to come and take the sulphate. So it's going to be ammonia and sulphate. See? But remember, any sulphate by nature it has a 2 valence, means any sulphate it has what? 2 negative. Sulphate it has a 2. So these 2 here is going to come under here. It's going to come under here. Make sure you put your bracket and then you remove the one on top. This is a radical, right? It's something you memorize. Like any sulphate, when the sulphate is alone, it's always like this. And when the ammonia alone, it's always like this. NH, NH4 plus. So when you put them together, let me show you how we put them together. So, but you can just simply memorize. Don't waste a lot of time. Negative. So look, so I'm going to take this and this together right now. So these 2 is going to come under here. So you write your bracket. So bracket is going to be 2, and here is just a 1. 1 is going to come here, and this will remove. So 1. But you don't have to write anything with 1. 1 you can just ignore. That's how they got this right here. But just memorize, simple step. So we plus. So you see, this one and this one they go together. And where these 2 come from, it always come from the sulphate. See, as a radical, like I say here, by nature it has a 2 negative. So what you left with? You left with it OH and H2, which is H2O meaning. So you can simply memorize this ionization. So if you take acid and base, for this case, this is what you got. You can memorize that equation. Okay. Now I don't want to spend a lot of time here. Okay, I want to get to the point because that was not part of the very crucial thing about the experiment. Okay, now let's go. Okay, so then the next thing here, then the next things we're gonna need all these apparatus. So this experiment here, if you've been in my video or if you watch my program, then I explain all of this, how to do this experiment. Okay, so the equation is under the link below. If you can see, let me know. So you do the experiment. When you're done, now there's a question. So the question of answer for you. Now they say, okay, what is the meaning of these signs? This is oxidizer. This sign here is what is? Oxidizer. Actually, I have all the signs here. You can come and memorize them, you know, or you can just Google, find on the social sites. This is the meaning of all these signs. The first one, what does that mean? The second one, what does that mean? But the one that we have there is oxidizer. Same as this one, oxidizer. The first one is oxidizer. So the first one is oxidizer. You see, but you have all these signs, like I say, you know, you can simply come and this is a toxic substance, irritant means it's going to be irritative. Okay, health hazard, and these environments, all of them you can just simply memorize. Okay, but let's go to the one that they ask us. We don't want to waste a lot of time. Let's get to the actual question. Now from the question here they say, okay, answer after you done the experiment. Now they say, okay, this is the answer sheet. Answer. Okay, this one here represent what? Oxidizer, or you can say oxidizing element. And the second one is toxic substance. That's what you got as Q, toxic substance. The third one is harmful or irritant. The fourth one is corrosive. A good example is acid. Acid is very, very corrosive. You see, that's why from all this, given that, yeah, I can go back here just a second. Remember, this is stuff I'm gonna need in a preparation of copper chloride. Means you have a hydrochloric acid, copper chloride, hydrated, and sodium sulfate. So if you come back here, now they say out of all of these above, we have to identify here. That's what I say, oh well, I know. So okay, well, I know most of them. How? Look. So we know the first one. This is the first one. We just say now. Oh, that's just me. It's kind of freezing. Just a second, Femi. Oh yeah, I got it. Okay. So we say this is oxidizing element. Okay, the second one is toxic, so you can just write down, and the third one is harmful, and the other one is corrosive. Corrosive, for example, hydrochloric acid. They say give example, which of the chemical above, out of those above they gave to us, is corrosive. Hydrochloric acid is corrosive, and something which is irritant or harmful is copper chloride. Copper chloride can be irritant or harmful. And the toxic one is going to be sodium sulphate. Sodium sulphate is toxic, and then oxidizing agent, copper, dehydrated, this one. But also you can do your research and see, and if you identify any mistake I've done, please come and say, oh, you know what, that one is supposed to be like that, you know. Okay, now let's go to the next one. So I was here. Okay, now you done the experiment. Now they got a question for you. Okay, what is the title of this experiment? The title of this experiment is preparation of, you see here they say title of this experiment is preparation of copper 1 chloride. We want to prepare copper 1 chloride. That's a title. Now they say reaction of the equation. To reaction of the equation, these you can simply memorize. You see what I'm saying? If you do experiment, they should know how all of them three. This is the first one. You do means you take a copper chloride. No, you take sodium sulphate. Okay, let me just catching up for some people missed this. Okay, so what you do, take your sodium sulphate, and then what you do, you take that dehydrated what copper, you add on, you react them together, and then what happens? You're gonna get what? Sodium sulphate, and then hydrochloric acid and copper chloride, 2 copper chloride. And then next, take your sulphuric acid and then ionize it, which I showed you before. Means look, remember you had what? Sulphite. See, sulphite. So this is SO3, and then means when they in there, they're gonna ionize. You're gonna have what? Sodium, sulfur dioxide, and then water. This sulfur dioxide, this is water. So what happened? Look, you can simply memorize because they don't want to change anything in this. Just memorize. Okay. So what happened? Look, we're gonna take this copper chloride. So sorry. So what happened? Look, take this copper chloride here, and then react with these two. See, sulfur dioxide and water, and then it's going to give us finally sulfuric acid and copper chloride and hydrochloric acid. But this is what you want. That's what you want. That's all. So just memorize the equation, and that's all. That's all I need. Okay. Okay. So for some people who need, like I say, PDF, I'll put for you. Man, my eyes are red. I didn't sleep last night. 7 a.m. right now. Okay. Now, so let's say here, when you do your experiment at first, remember you take your sodium sulphate, you measure, you weight it, you put in a weight. How do they call this weight one? Sodium sulphate, and you put in a weighting board. Weighting board, that's more apparatus here. You can weight your stuff. You put in a scale. You say, okay, it's 5 grams, whatever. See. So now let's say here, come back to the equation. So let me come back to the equation. Sodium sulphate must be weighted. So you weight your sodium sulphate, and then weight from the balance that was added. Here I don't clearly understand what trying to mean, because we know our weight is 5 grams. What do they mean when they say weight from the balance that was added? Because 5 grams, and then we take the 5 grams, we put in a weighting pot, and then weighting pot we could put in a beaker, and then we weigh. I think maybe you can, after you measure a scale, and what do they mean here? Weight of the balance that was added. Weight from the balance that was added. I think what they're trying to mean here is, like, you know, there's that little error when you weight anything. Let's say it's 5 grams, but when you put in a scale, it could be 5.05. That uncertain. So, but you can also try to discuss. Tell me what you think. You see, because I tend to, I understand, but I want to have your point of view on this. Weight from the balance that was added. I think, let's say for example, my weight is 87 kilogram, 87, 89, 87 kilogram, almost 90. Okay, by 87. So now if I go to the scale, right, my weight is gonna show me sometime 87.4. So that ascertained, I think, after when I go to the balance, means if I go to the balance, the weight is gonna be. So I think that the mean number plus or minus what 0.5 what gram. It's like that, weight plus 0.5 what gram plus or minus. But please confirm with your classmate, with whoever you do experiment with, and then also you can tell me what, or tell me what you think. What is on your mind? You know, I'm trying to read this sentence. It's clear, but it's, you know, I just want you to hear your point of view. Same here, I did the same thing. I say, okay, because they give us the 6 gram of dehydrated copper chloride. Now the one weight from the balance that was added. I think if you take that 6, you put in your balance, because they say, for example, they say, okay, take 6 copper chloride. Means I'm going to take copper chloride, but when I put in the balance, it's going to be slight and certain, like maybe slight a little more, like maybe 6.05 or 5.0. You know, that's a little increase, my thinking. But let me know about your thinking process, okay? And then let me know. So for me, I just say 6 plus or minus 0.5, but let me know what you think. Maybe I misunderstood the sentence, because the problem here is me, maybe probably I don't understand clearly the sentence. But as far as my understanding, you have your 6 gram. So if they say weight from the balance, means from that scale which was added, so means which is going to alternate a little bit. That's to say that weight plus 0.5. I can show you there. Okay, now let's go to the next one. Like I say, all these hard copies available. Now let's go to the next one. Okay, so now they want to answer these results. The first one, they say, what color do you observe for the solution sodium sulphate when you mix with the water? So when you start the practical phase, remember, you take sodium sulphate and then you put in your glassware. When you say the glassware, these are glassware here, don't get confused. Okay, these are glassware, means those one here, beaker, graduated flask, conical flask, cylinder, measuring cylinder, all of these are glassware. See, all these on here, glassware, the one I just show you there. So let's come back here quick, we can finish up. So when they say what color do you observe when the solution of sodium sulphate is in the water? So if this stuff is in the water, remember your water, you're going to warm a little. You put in a glassware and then you warm a little, but do not boil it. Okay, you just warm a little bit on a heat. So you're going to have like a plate or heat in a computer lab, in a chemical labs. Okay, so what you're going to see, you're going to see some yellow when in a warm water. You're going to see what? Some yellow solid. See? In a warm water. Yellow solid in a warm water. I don't know why did I say when here. Solid in a warm water. In a warm water. Yellow solid in a warm water. Okay. The second one, they say, what color do you observe when the solution hydrated copper chloride is in water? Okay. The copper chloride, we did this practical. You can watch my previous video. The crystal turn bright green. You're gonna see like a kind of greenish, sort of greenish, and then it's gonna get like darker greenish to the slighter blue tinge. You see? That's what I say here. What happened is the crystal is gonna turn bright green with a slighter blue tinge in the water above the crystal. That's all. Now, 5.3, they say which ion responsible for color that's observed in the copper chloride. Okay, so that's what we call cupric ions. Memorize this. Okay, these are cupric ions, see, which are responsible for the color that you see in copper chloride solution. And these cupric ions, it tend to have a blue color when dissolved in water. That's all. Okay, memorize that. Also, you can see this kind of start to get greenish, and then bluish tang a little bit, you know. So that's responsible for that color that you see in copper chloride, because your intention to produce copper chloride, just like I was seeing a solution in a chemical equation here. Yeah, chemical equation. Okay, so this is our intention. Like I said, this is our intention here. produce there. See? Okay, now let's go to the last one. What observed in sodium sulphate solution is added to the copper chloride? So we saw a light blue. The solution is, what is it? Let's see, light blue here. So it's my light blue. Light. It's like this, light blue. See, light blue. Sorry, my handwriting. Light blue. Okay, it's a light blue. Light blue. Okay, I hope you can see that light blue. Light blue. That's all. Now, which gas smell when? Okay, so the gas that you're gonna see, look, is this one here. Sure. So this is the gas you're gonna see. Sulfur dioxide. Okay, that's the gas you're gonna see. So that's the gas. The one. Let's say. Which gas? Okay. Which question I'm at now? I even forgot. Oh, number 5. Sorry. There's a which gas? Which gas smell when sulfuric acid is added? So the gas is going to be sulfur dioxide. Sulfur dioxide. This one. And this sulfur dioxide is colorless. You cannot see it, like maybe it's yellow, blue. It's colorless gas, and it has a strong choking odor, like strong choking odor. See what I'm saying? Okay, let's go to the last one. But okay, the last one, they say what color of calcium chloride when it's filtered with a bunched burner? So the color is going to be white powder. You see, if you watch the previous experiment when you explain the whole copper chloride when it's formed, it's going to be something like a whitish. See, white powder, or sometimes it can be solid, slight green, because it was oxidized with the impurities. So white powder or solid slight green from oxidized impurity. Okay, 6.2. For the 6.2 here, they say, does the color of copper chloride remain the same when you leave it dried in the atmosphere? No, it's not going to be the same. See, it will not remain the same. When it dry out, it's going to form what? Green crystal. When it's dry again, it's going to form green crystal, so it's not going to be the same. Okay, so for yield of the product, what the yield of the product means, remember your intention to produce a copper chloride. Now, the question, we have to use those balanced chemical equation to produce the yield of the products. And this I'm going to do on the next video. So, because now I don't want the video to be long. So if you FaceTime here, please just come right here, subscribe to this one, channel. Wabantu Academy, subscribe and see here. You know, I do a lot of projects, community works, and I do for the continent too, and all the closer group just to motivate people who need a time, you know, inspiration, and also have a giving back program, feeding homeless, feeding vulnerable people, you know, with little we have. They say sharing is caring. Don't afraid to share. It doesn't mean that you're gonna be you're gonna fall. No, the more you give, the more you receive more blessing. Don't afraid to share, because you know you might have yours, you think it's too small, but you know, sharing too little, you can uplift someone out there. So you know, you see me there, that's me right here when I was a baby with my beautiful mom. That's me, baby, when I was a baby, and that's me when I was 4th grade. You see what I'm saying? That was 4th grade. This one, I don't even know how age it was there. I think less than a year, I think so. Okay, so my mom did keep picture for me. So we can stop here and also go to Trying Course. Trying Course is the program where we feed homeless, like I said, inspire with the little we have. You see what I'm saying? Go there, show some love, subscribe, share, so you can get the automatic notification. Thanks a lot, and I think I'll see you very soon for yield. Okay.